Hi Priyanka, how are you doing?
Hi, Costa. Good, I'm good. How are you?
Great, good. Doing good, doing good. Thank you. So we'll start in another couple of minutes, just waiting for others to join.
Yes.
Hi Seema, how are you doing?
Yeah, I'm doing good. How are you?
Doing good, thank you.
Mhm.
Okay, great. So let's dive in, guys. Let me share my screen. So we already had a couple of sessions on Python, and what we tried to understand was kind of the fundamental things, the fundamental operations that we can do on using Python programming. And today we are going to take one step further. So let's see what are the things that we're going to discuss today. So there is a bit of change of the plan that I had earlier because I thought that today I will show you both the functional programming paradigm and also the OOP programming paradigm. But then later I thought that let's not rush probably, like with the OOP part right now, okay, because we can take it one or two sessions down the line. Before that, let's understand a few things about, know, handling data, leveraging Python and everything. Hi Mohanraj, how are you doing? Welcome to the session.
Hey, doing good, Gustav.
Great. So the plan now over here is we will first see how to leverage Python to handle the data, to do some fundamental data analysis, and also definitely how to leverage the function, because that is the first thing we want to understand. We want to see before we go ahead with the OOP part. So probably we can take, we'll see OOP maybe today, maybe tomorrow, or maybe on Thursday. But by this week, definitely we will see how to leverage OOP in uh, Python program. Okay, because and also I will tell you that why this object-oriented programming is so important. Okay, great. So with that, uh, let's start. So agenda for the session. So agenda for the session. First, we will see data ingestion, notebook setup, then data ingestion. Then we will see fundamental EDA, fundamental data exploration, one, fundamental data exploration, two. What is the difference between one and two? We will see that. Also fundamental data exploration 3. Then we will do some uh, fundamental data operations. Then leveraging functional programming. Now, this part number 7, this is for now is optional for the day, and we'll see if we can take it up in the session today. Because I don't really rush with the things. So when we start with the initial few sessions, okay. Great. Now, why notebook setup? Because for the last two sessions, what we were doing pretty simple things like creating some data structures, creating some fundamental objects, doing some basic operations like indexing and all these things, okay, or checking a number whether they're odd or even. So we didn't really have to get data from somewhere else, okay. However, in the session today, what we have to do, we have to connect to a data source and we have to get the data from there. Okay, so in this case, what we will do, we will connect to like the drive where I have the data, and I will get the data from there. So now I have to set up the notebook so that we can connect to the drive and we can get the data from there. Uh, However, if you are working, on standalone notebook, that means you're not working on the collab notebook. You're not working on cloud. You have downloaded the Anaconda environment and you have launched the Jupyter notebook and you're working from your system. Then the like you do not really have to set up the notebook in the way I have to do. You can skip a few steps. Uh, but then again, like if you are connecting to a database and you're getting data from some SQL data sources, uh, then the process will be a bit different. So what I'll do as well after the session, like in this notebook, I will also include uh, a link which will help you to get data from some SQL databases if you have to. Okay. Uh, or I will always suggest that you go through those links as well, because in the interview you can also be asked, okay, that let's say you have some data in a SQL database. It could be PostgreSQL, or it could be Oracle database, or it could be MySQL. So depending upon a SQL database, how would you get the data from a particular SQL database? Okay, so for that, I will share a link with you in this notebook itself, so that you stay aware of it. Okay, great. So to set up the notebook, what I'll do, let me do it one step at a time. This session only, because after this session, from the next year onwards, we can, like do it in one go, because you will know what I'm doing. But for this session, let me take it one step at a time. Okay. So the very first thing, what I'll do, I will just, um, so I will start with from google.colab import drive, and then drive from content drive. So I will show you what will happen. it will first connect to the server and then it will seek the permission, connect with the drive. So I hope you can see that there is a small message that permit this notebook to access your Google Drive files. So so what I'll do, I'll click on this, connect to Google Drive. And I will take you to this sign-in page as well, so that you can have a look at it. So you can see that it wants to connect to my Google Drive. Okay. So great. So let me share my screen and let me take you to the notebook once again. Because I have connected to the drive, and that's why I got anyway, the sharing stopped. Now let me show you something before we go ahead and dive deeper. Let me just open the drive so that you can see. So you can see here that this is the drive, okay? This is my Collab notebook, Collab drive in the Google Drive, where I have kept a lot of files, the data files that we will use in this particular program. Okay, so that's why I have to connect to this particular drive. Okay, otherwise I will not be able to, this particular folder on the drive. Otherwise, we'll not be able to get the data from here. So let's go back. So for this, what I'll do, I will import OS. Connecting to establishing connection with Collab folder in my drive. So I'm just making explicit, comments so that we understand what needs to be done step by step. So the first thing that I'll do is I'll have to import this library called OS, which is for the operating system. Okay. And why? I will show you that. First, let me do this. Now, if I write OS dot, and I will get a lot of methods over here. One method is get CWD. So this get CWD will give us my current working directory. Okay. So what is my current working directory? So you can see the current working directory is this. But what we have to do, we have to connect to this Collab folder within the my folder. So what I'll do, I will go ahead and with and I will write OS dot chdir. This is for to change the working directory. Okay. Now over here, what I'll do, I'll give content drive, my drive. So let me put the comment over here that chdir is for changing the working directory. Great. Let me execute this. And now if I write os dot get cwd, just to confirm that the working directory will be changed, you can see now we are connected to the drive from where we are going to get the data. Okay. So this is about the notebook setup. Now, what next? We have to get the data. So data ingestion, for data ingestion, what we'll do, we will do it in two parts. First, we will import the pandas and the NumPy library, though you do not really require the NumPy library, but like for ingesting data. However, you can say it's a kind of, like when we are importing the pandas library, we also import the NumPy library because these two libraries are being used often. So some important libraries. So import pandas as PD. This PD is alias. You can, and it's a kind of norm that we always give PD. Okay. You might think that, okay, we have to give PD always. No, you can give some other name, but then, it will be confusing. So, import NumPy as NP. So in one of the interviews, I actually asked, like an aspirant, that okay, what will happen if I write import pandas as NP and import NumPy as PD? Okay, and I go ahead and I do the analysis. Will it work? So the candidate said, no, sir, it will not work. Like we'll get error. I said, no, will not get error. Why? Because it's just an alias. You can give any alias, but it's a norm that we give this alias just to like avoid confusion. Now it's not his fault. Why? Because like in all the blogs or curriculums or everything you come across, they always keep on writing import pandas as speed, without even telling that this is actually just a norm that we follow. So great. Now the second part is importing the data, importing a CSV file. Now remember, I have mentioned over here CSV file because depending upon the kind of file we have to like import, we have to give that extension. Now for importing a file, we use this pandas library, but I also tell you when not to use the pandas library. Okay, so I write over here and let's say I write data equals PD dot. Now we'll get a lot of options, lot of like pandas being a library is a kind of compilation of a lot of methods, attributes, everything. So what I'll do, I will straight away go to the methods for which we're interested. So I'll go to the read section. Now over here, you can see that there are a lot of extensions that we may use. Okay. Out of these, let me tell you something that CSV is not a very good method to store the file in your system. Why? Because it doesn't really give you a very good encryption method. Okay. Also, these files are not lightweight. Okay. So what are the other methods of, like if you want to really store a file in your system or somewhere and want to ensure that this file is well protected and well encrypted, you can go for Parquet, you can go for ORC. Okay. They are better options any day. Also, you can go for Pickle. Okay. So they are better options than CSV. Why we go for CSV? Because, when we like for the first time we, let's say, get the data from multiple data sources and we create a file to work on, CSV is a kind of easier way of getting the data into Python, and we can also open up the file and we can have a look at it. That is the reason. Okay. So what we'll do, we'll go with the read underscore CSV because we will read a CSV file. So let me first get the file over here, and then I will tell you when not to use the pandas library to read the data. So the file that we're going to read is cars.csv. Okay. And ensuring that we have imported the right file. So for this, go with the data.head operation. What does data.head do? It will give you the first 5 observations for the dataset. Okay, so this is the dataset that we have. Now, before even we go ahead and talk about the dataset and explore it further, let me tell you something. A lot of times, or most of the times, you will not really work with very small datasets. You will work with medium to large datasets. Okay, and in those cases, if you try to use the pandas library to read the data, then that is not a very optimal method, or that is not a very efficient method to do that. Why? Because it will take a lot of time. And also what happens when we use the pandas library, it uses your RAM capacity. Okay. Now, what if you have a system, you're working with a system in which you have 8 GB RAM, or let's say even on the cloud, you have created a cluster uh, with a RAM capacity of 8 GB, let's say. Now the data set that you are working with is more than 8 GB. Then can you use this pandas library to get the data into the environment? No, you cannot do that. Okay, because your data is exceeding the RAM capacity. So in that case, what you're going to do? Either you have to read the data in chunk wise. That is one option. Second option is you can go for more efficient methods like using PySpark, which is actually the Python version of the Spark. Spark is originally being written on Scala. Because what happens, when we started working with the big data, the core components of big data include uh, the HDFS or Hadoop file distribution system, then the MapReduce for the distributed computing or the parallel computing as we call them, and we also have the yarn, which is the a resource negotiator. Okay, it is being called as yet another resource negotiator. Now, what has happened over a period of time? We have realized, or the people have realized, that not all the operations are MapReduce operations. Now we have Spark, which is originally been written on Scala. Okay, Scala supports a functional programming a lot. Okay, however, Spark, to make life easier for us, like the Python users mainly, we have a Python version of Spark, which is known as PySpark, which uses a Spark operation but with a Python wrapper around. Now, what is the advantage of using PySpark? The advantage of using PySpark is uh, you can leverage the distributed uh, computation or the parallel computation. Okay, so that is why when you are reading the data, very large files, you can use PySpark, you can use the chunk, like reading the data in chunks. Also, you can use like libraries like Dask, which also uses the parallel processing. Okay, so these are the methods that you can follow when you are working with medium to large files. Okay, because over there, using this method might not be efficient. So great. Now let's go in.
Hi,
Yeah,
Kaustubh.
yeah.
I just wanted to know if we have a large file and we try to work like this, so will it not get imported or something like that, or will only half
Uh,
will get
See,
imported?
there can be two scenarios. If the file exceeds the RAM capacity, okay,
Mhm.
then probably you will end up not importing the file. Okay.
Okay.
However, let's say your file doesn't, uh, like exceed the RAM capacity, but close to it. Okay. Then in that case, you will be able to import the data, but when you will try to do any operation on it, it will take a lot of time. Okay.
Mhm.
So what I'll do there is, I believe there is a, uh fantastic video on YouTube, if I'm not wrong. Okay,
Mhm.
I came across once, I believe. There is a fantastic video on the YouTube, which probably also gives a demo of this. Okay, someone told me. I'll look for that. Okay, and if I can get something like that, I will share that with you. Okay, you can
Okay.
go through that also.
I'll also try to search it. I'll
Great,
ask you if
great, great.
if I can find
Okay,
it.
you're
Thank you.
welcome. So, okay. So fundamental data operations one. So what we're gonna cover here in this are some very fundamental things like head, which gives us the first few rows, then tail, which will give us the last few rows, then columns, the column names, shape, number of rows and columns, then info, complete data frame info. And what else? Yeah, before that, below C, customized number of rows, ILOC, customized number of rows and columns, and this number of rows. So fundamental data operations one, that we call over here, they are mainly for having a first look at the data. Okay, so there, like we look at the data from multiple aspects. So to have the first look of the data, to get a initial understanding of the data, we use these operations. Okay, so let me show you. So the first one is head. Okay, Now over here, we give data.head, it will give us the first few rows, the first 5 rows to be specific. Okay. Now, what is this data all about? We have manufacturer, model, type of the car, origin of the car, drivetrain. Then we have the, like what is the engine size of this? What is the cylinder? How many cylinders a car has? The horsepower, mileage of the car in the city, mileage of the car in the highway, weight of the car, then the wheelbase, and then length and the uh, manufacturer suggested retail price. Now, when you have this data, what you are supposed to do? You are supposed to understand which variables you are working with. What are these variables all about? Okay, so you will have a data dictionary, or you will have something known as uh, analytics based table, which will comprise of the information regarding these variables. So we also need to understand, we also need to map that whether we need these variables for like our project or not. And a lot of times we also have a meeting to decide which variables to include and which variables we might exclude from the analysis. Okay. Also, why do we do this? To understand at the very first stage that whether we have got some blemishes in the data or not, some quality issues in the data or not, without even diving deeper. Now, the second case that we are going to see over here is head, but with customized number of rows. So over here, if I write data dot head and then I give 7, what it will do? It will print the first 7 rows. Remember, since it's head, it will always start from the top. So we get the first 7 rows. Similarly, we go ahead with the tail, which is about the last 5 rows. Yeah. And then customize last few rows. So if I write data.tail and give 10, so it will give us the last 10 rows. Okay. So you can see that for both tail, we'll get the last row. So last 5 or last 10 or last whatever, it depends on the value that you give over here. Now let's say that you want some rows from anywhere in the data. Okay. So you can see one thing, that the index starts from 0 and ends at 427. So you can get an idea that we have 428 number of rows. Now let's say you want to start from index 100 and you want to go up till index 110. Okay. So over here we have LOC, that is locate, and within the locate we give the range. So R1 to R2, that is from where to where. So over here, let's say I give data.loc and I give over here 50, 60. So what will happen? It will start from index 50 and it will go till index 60. You can see. Again, why do we do this? These steps we take to understand that whether we have some quality issues in the data. You will connect with this much better when we will have a session on handling the missing values, which will be, I believe, two to three sessions down there. Probably the first session in the coming week, it will be on that. So great. Now let's say that can we use LOC for selected rows and columns. Why I have put this question? Let me put it as a statement. We can't use. So let's say I want selected rows for selected columns as well. So let's say I write data dot LOC, and now over here I give 50 to 60, and also I give 2 to 4. That means for column number, for index column 2 and 3. Why 2 and 3? Because 4 minus 2 is 2, so we need 2 columns from position number 2. Okay, so if we want selected rows for selected columns, can we use LOC? We cannot use LOC. Okay, because it cannot do the slice index with the on the columns. So what we have to do over here in this case, we have to go for ILOC. So let me see, plus 5, so it's going to be 6. It's ILOC. And in ILOC, what we do, we give R1 to R2, also C1 to C2. Okay. So over here, we write data dot ILOC or ILOC. And now if I write 50 to 60 and 2 to 3, 2 to 5, let's say, what will happen? It will start from index 50, but it will go on up to index 59. It will stop right before 60. Okay, why? Because 10 rows starting from index 50. Similarly, it will go for 2, 3, 4 column index. Okay, why? 5 minus 2 is 3. So 3 columns starting from index 2. So you can start, you can see here 50 to 59 and this. The next is shape. Okay. So data dot shape. So shape is an attribute. Okay, you can see that I haven't given any kind of parenthesis here. What is an attribute? It's a characteristics. Okay. However, where like we could say that I gave parentheses in some cases, they were the methods. Okay, I'll explain these methods and attributes in the session on OOP. So it means that we have 428 number of rows and 14 columns. Now let's say that you want only the number of rows. We can say it's a tuple. Okay, the resultant object is a tuple that we have got as an output. So you can always use indexing on this. So now if I write data.shape and I give over here 0, it will give you 428. Similarly, if I give here shape 1, it will give you the number of columns. Okay. Sorry. Mistake. I haven't executed that. Okay. So you can see that we have got 14 columns. After that, we look at the columns. It will give you the column names. Now, why do we need them? You will see. Why do we need them? For now, let's just look at it. So these are the columns that we have in this data. Then what? We have info. This is very important. Data.info. It gives us complete information on the data set. So what are the information that we get? The first information that we get is the data frame. Second information that we get is how many rows we have. Okay. Then how many columns we have. And for each column index, the column name, and this is the number of non-missing values that we have for each column. We know that we have 428 rows, and you can see here it tells us 428 non-null. That means they are non-missing. For example, if you look at cylinders, for cylinders you could see here it's 426 non-null. What does it mean? That for two entries there are missing values. We'll see that. After that, we have this data type. Okay, that what is the type for each variable or each column. So this is, and then we have got a very important information that a lot of people tend to ignore is the memory usage. This tells us that how much capacity of your RAM is being exhausted. And also I will show you how to reduce this RAM capacity. Though over here it is very less, but still I will show you a hack which will help you to reduce this RAM capacity if required. And finally, we use is null. So data dot is null dot sum. This gives you the number of missing values for each variable or each column. So you can see here that for cylinders we have got two missing values. So these are the fundamental data, like data exploration one, where we try to understand the data that we have. After this, we will go for fundamental data exploration 2, which is more about the descriptive statistics, measure of central tendency and the measure of dispersion. So over here, what we're going to do, we will look into describe, which will give us the descriptive statistics. Now, how to use that we will see in the session where we will talk about the outliers, how to interpret them. Today, we will just look at the operations, the descriptive statistics. Second, we will look into value underscore counts. This is for the frequency distribution. Then we will look into skew, which is the skewness. Then we'll look at the kurtosis, which will give us the kurtosis value. Okay. What else? Descriptive statistics. Okay. Group. Multi-factor. So we'll understand this. So 11 data.describe. This will give you sorry. This will give you the number of non-missing values. Okay, first for the numeric variables. Second, the average, that is the mean, STD, standard deviation, minimum value, first quartile, median or the second quartile. Then we have 75 percentile or third quartile, and then the maximum value. Okay, Again, how to interpret, I'm not going there, you will understand that in the session on outliers. After that, we will go for value underscore counts for the frequency distribution. So for example, I write over here cylinders dot value underscore counts. It will give you the absolute numbers. Okay, so for example, there are 190 cars with 6 cylinders, 136 cars with 4 cylinders, and so on. But what if you want the relative distribution? Okay. So for the relative distribution, there are two methods. I'll show you both so that you know both the methods. One is you can directly use the option here, normalize equals true. It will give you the relative distribution. Okay. So 44%, 31% like that. However, there is another way, there is a logical way. Let's say you have forgotten this normalize equals to true, but still you want the relative distribution. So what is the relative distribution? It is this number divided by your entire length of the column. Okay. So what you can do, you can write okay. So you can see that you will get the relative distribution in both the ways. Another important thing that I've missed out over here is any unique categories. So what is this n unique? It will tell you the number of unique categories that you have. So if I write data cylinders, or let's say type dot n unique, what it will tell us, how many types of cars do we have? You can see that there are 6 types of cars we have. Now, what is the benefit of using this? We can understand that whether we should look into the frequency distribution or not. So, for example, for 6 types of cars, it makes a lot of sense to look into the frequency distribution of the cars that we have. However, if I go for, let's say, model, and we check how many models of cars do we have, we can see the value is 425. So does it really make any sense that for 428 number of observations, we have 425 different models? And should we look into the frequency distribution of 425 models? No, there is no, like sense of doing that. So using this, we can also prioritize that how to go about the data analysis. Then we look into further is the skewness. So data. you can see the skewness. Now, again, skewness tells us the distribution of the data, how the data being distributed. I'll go more over this on the outlier session because the entire session on the outliers and the extreme values will depend on this. But why am I showing you the codes today? Because so that we do not really have to spend a lot of time on the codes, understanding the codes. And fifth being the kurtosis. So data, look at the kurtosis. The kurtosis value is 0.5. Okay. So this is the fundamental data exploration part 2, where we look into the descriptive statistics. Part 3 will be more interesting. Why? Part 3 fundamental data exploration. This is going to be the visual analysis. So first we will see dist plot from Seaborn. Second, we will see histogram from Plotly. We will see the box plot from Plotly. So plot now when it comes to the visualization, there are multiple libraries that we have in Python. We have Matplotlib, we have Seaborn, we have Plotly, we have Bouquet. Now, out of these, Matplotlib is definitely the grandpa. Okay, Seaborn is a better version that we have, but Seaborn is again a static library. What is the difference? We'll talk about that. Plotly that we have nowadays is a fantastic library. Okay, once you will use Plotly, probably will not really use any other library. Okay, I mean, like I use Plotly a lot. I mainly use Plotly for multiple reasons, and you will see that. So the first thing that we will do is importing the libraries for visualization. So we'll import Seaborn as SNS. I will mention it over here. Seaborn is static library. And plotly.express as px. Okay. So the first one is dist plot from Seaborn. So I can write SNS dot dist plot, and over here I have to give the variable. So for example, I give engine size. Also have to give the next step. 6%. Why I have given this so that we can get the output right in the same cell. So it will give you the distribution that it follows. Okay, so you can see the distribution and you can get an understanding, first-hand understanding of the kind of data we have. However, next we'll see histogram from Plotly. So for that, what we will do, we'll write px dot histogram. Now over here, first you have to mention the data frame that we want to use. So I write data. Second, the variable that you want to use, that is engine size. And then you can also give a title. Okay. So histogram for engine size. And then we have to give this dot show. Otherwise, it will not produce the output. Now look at this. Why this is so beautiful? Because on the x-axis, it gives you the variable that you're using, engine size. On the y-axis, it clearly gives you the count for each bin that we have. Now, if you look at this entire distribution, you hover your cursor and you will get the value as well. So for engine size 2.4 to 2.5, you have 49 cars. So you can clearly understand the number and the participation of each group. So for example, if you go here, you can see that between 8.2 to 8.3, there is only one. So you can interact with the entire dashboard. That is why we call this as data. Similarly, we will look at box plot from plot. So px dot box data engine size. So and dot show. So again, now how to interpret this, we will understand. I'm not going into that. Okay. So this is the part 3 for the fundamental data operations and data exploration. Now let me show you a small, part of what kind of data operation that we may do over here before wrapping up. We'll see two operations. What are they? Or three operations. First, we will create a copy of the data frame. Why? Because a lot of times we want to do the analysis on the copy, not on the data frame that we have created after importing the data. Two, we will reduce the we'll reduce the memory usage. And third is we will separate the numeric and the categorical variables. So for the copy, we will import copy. Simple. And now let's say we want to create a copy, data underscore copy. And over here, we go for deep copy. I'll talk about more about the deep copy in the upcoming sections, like why we have gone for deep copy. Now, if you look at the data underscore copy dot head, it will be the same data. We have just created a copy. Now, the second thing, so creating a copy. Now, copy, let's see in the memory usage, data underscore copy dot info. Okay. So you can see that the usage is 46.9 plus KB. Now it could have been in megabytes or gigabytes as GB as well. Now let's say you want to reduce the pressure on the memory. You want to reduce the memory usage. So what you can do for all these float 64 and integer 64, you can reduce the byte size. So what I will write over here, I will write for reducing the memory usage. Okay, reducing the memory usage. So I will write for in. Now over here, I'm referring to the data.columns. You can see we saw data.columns where we got the column names. Now I'm using that. For in data.columns, what I will do, I will check that if not data.columns, I will use the copy. I will check the data type that we are using. Okay, how? Using the .d type. And I will see that whether it is equivalent to float 64 or not. So if it is float 64, what I will do, I will write data underscore copy I equals data underscore copy I. Now I will write over here dot as type. So I'm converting the data type from float 64 to float 32. Also, if it is not float 64, I will check whether it belongs to int 64 or not. That is integer 64. And if it is integer 64, then what I will do, I will again convert this to int 30. If both the conditions are false, then I will not do anything because then it will belong to object. So now once I execute this, and if you see data underscore copy dot info, now you can see the memory usage is now 31.9. So we have almost reduced the memory usage by 33%, and that this will not affect your operations on the data. Okay, so just imagine if you have got, like data frame of, let's say 1 GB, 2 GB, and you have imported the data, you want to use the pandas operation. But with 2 GB, you are facing, you are struggling, and you use this, it will be reduced by 1/3 to 50% as well, depending upon the kind of variables you have. So, and this is a great hack that you can use easily. And the third one is let's say I want to create two data frames, one with the numeric variables and another with the object variables. So what I have to do first, I will create two empty data frames. So for example, I create data underscore now pt dot data frame and then data underscore cat equals pt dot data frame. Okay, so these are two data frames, both are blanks. Now what I'll do, I will check. I'll simply check whether they're object or not. If they're object, it will go to data underscore cat. If they're not object, irrespective of being float or integer, they will go to data underscore now. Then what I'll do, I will write data underscore cat data I else data underscore now I equals. That's it. So if you now see data underscore cat dot head, it will have all the object variables: manufacturer, model, type, origin, and drivetrain. And if I write data underscore num dot head, it will comprise of all the numeric variables. A lot of times we do this segregation to do separate kind of analysis. Okay. So we are going to stop here. I will not really go with the functional programming today because we are already running out of time. As I said, that I will take things very, like in a way that all of us can follow. Tomorrow we'll see few important things on data operations, okay, which are quite important when it comes to data preparation stage. And also we'll see how to leverage the functional programming as well. Okay, because then in the next session we can see the OOP part as well. Okay. So yeah, great. And meanwhile, I will share this recording along with the note. So see you guys tomorrow, same time. Till then, take care. Have a nice day.
Bye, Gustav.